Today we're doing 8b.6, apply the three properties of logs. Okay, so logs are exponents, so the rules for logs are similar to the rules for exponents. So for instance, if you had two exponents, you have x squared times x to the third power. With exponents, you would end up adding those, and you would end up with x to the fifth power. So the same goes with logs. If you have a log and see how these two are multiplying when they're side by side, they're multiplying, you could end up separating these into two logs and adding them. Okay, and you can go backwards as well. So if you have two logs that are adding like this, you can go backwards and you can change it to one log where they're multiplying. So here on this example, log base 6 of 3x can be separated to log base 6 of 3 plus log base 6 of x. So you need to remember that multiplying and adding go together. Okay, when you get to the quotient rule, when you're dividing and subtracting go together. So here's the rule. If you have log base b of m over n, that can change to log base b of m minus log base b of n. So here again on this example, log of 17 over 3, that can change to be log of 17 minus log 3. Okay. So when you go to the subtracting, that is called expanding because you're making it longer. And when you go to the division, that would be called condensing. Okay. So this is the expanded way. This is the condensed way. Okay. The power rule, if you have a power, you end up multiplying. So notice here how m is to the nth power. You bring the power in front and you multiply it to the log. Okay, so log base 3 of y to the fourth, we bring the 4 in front and you have 4 log base 3 of y. Okay, here what they're saying is that if you have log of 4, you could rewrite that as log of 2 squared. And then you would end up bringing the 2 in front, and you'd have 2 log 2. Okay. And going backwards just a little bit, I forgot to show you over here. So remember, if I had exponents and I had log to the fifth x to the fifth divided by x to the second, we subtract those, 5 minus 2, and we get x to the third. Okay, with powers, how it goes with multiplying, if I had x to the third raised to the second power, we multiply powers to powers, and that's how we end up with x to the sixth. So notice here again, this, when you're multiplying, we added the exponents. When they're dividing, we subtract the exponents. And when you have powers to powers, you multiply. Okay, so our first examples here, they want us to expand. So that means they want us to make them bigger, okay? And it just says that sometimes you have to use more than one rule to solve. So basically you're separating this as much as you can. So what I notice here is that I have a 2 and an x to the fifth, and they're right next to each other, which means that they are multiplying. So multiplying and what go together? Adding. So I'm going to end up changing this to log of 2 plus log x to the fifth. Okay, and then I notice that I still have an exponent. So I'm going to take this 5 exponent that's right here, and we multiply that, we bring it in front. So I have log of 2 plus 5 log x, and that is my answer. Okay, so example 2. We have now natural log of 7x squared divided by y to the third. So dividing and what go together? Subtraction. So I'm going to change this to be the natural log of 7x squared minus the natural log of y to the third. Okay, then I notice, wait, there's a 7 and also an x squared, and those are multiplying. So what goes with multiplication? Addition. Good. So we're going to do the natural log of 7 plus the natural log of x squared minus the natural log of y to the third. And then hopefully you notice that you still have these exponents that are in front. So here I need to take this 2 and bring that in front, and I need to bring this 3 and bring that in front. So I end up with the natural log of 7 plus 2 natural log of x minus 3 natural log of y. And that is my final answer. And that's natural log. All right, example 3. So we have log base 3 square root of 9x. Okay, so the square root of 9x, I would probably change that to be log base 3 of 9x, and which power would that be to? It's going to be the 1/2, because there is a 1 exponent in here, and then there is a 2 there. Okay, so then this 1/2 is going to both the 9 and the x. So now what I'm going to do is bring that 1/2 in front, so it's 1/2, but this whole thing is the 1/2. So I'm going to put in parentheses log base 3 of 9x. Okay, so then now these are multiplying. So we would have 1/2 and then log base 3 of 9 plus log base 3 of x. And then we'd go ahead and get rid of those parentheses, and so I'd multiply 1/2 through here, and so I'd end up with 1/2 log base 3 of 9 plus 1/2 log base 3 of x. And that's my answer. And the reason why both of them have the 1/2 is because the 1/2 was originally over the 9 and the x. It wasn't just with the x, the square root was over both the 9 and the x. So that 1/2 has to go with both the 9 and the x. Okay, and then example 4. The only thing I notice on this one is that there's an exponent. So all we're going to do is bring that exponent down in front, and we get 3 log base 2 of x. And that's my answer. There's nothing else to simplify. Okay, so that was expanding. That was making things bigger. Now we're going to talk about condensing, where we make things smaller. So if they both have the same log base, so both of these are log base 3, we can condense them into one single log. And so I'd end up writing this as log base 3, and then 5 and 20, they're subtracting, so that means subtraction and what go together? Division. So we're going to write that as 5 divided by 20. Whatever's first goes on top, second goes on the bottom. And then you'd want to reduce if you could, and we can reduce 5 over 20. So we end up getting log base 3 of 1 over 4. And that is my answer to my condensed. Okay, over here on example 6, everything is adding. And what goes, adding and what go together? Multiplication, good. So, and they all have the natural log, they're all in the same natural log, except for, I just noticed right now, what is right here? There's a 2 in front. So that 2 ends up becoming what? You're going to bring it up, and it's going to become your exponent. So I'm going to rewrite this. I have the natural log of 6 plus the natural log of 4 plus the natural log of x squared. Next, what we'll do is we will go ahead and take care of our addition, which changes to multiplication. So I have the natural log of 6 times 4 times x squared. And then we can simplify that by multiplying the numbers together, and we end up getting the natural log of 24x squared. And that is your condensed answer. Oops. There it is. Okay, so I'm going to give you a chance to try example 7 on your own. So I'm going to give you about 30 seconds, and I want you to condense that. Okay, so hopefully you got a chance to try that on your own. The first thing you should have done is taking care of that 1/3 that's in front, and that ends up becoming an exponent. So that will be log base 5 of 4 plus log base 5 of x to the 1/3 power. Okay, next, because it's addition, you're going to write this as log base 5 of 4 times x to the 1/3. And then that is just the same thing as log base 4 of x to the 1/3. And that's your answer. Oops, I forgot my base 5. Okay, example 8. Again, we have to always take care of these exponents first. So I'm going to bring that 5 up here. This 7 goes up here. This 4 goes up and up there to the y to the 4th. So we end up with log base 4 of 2 to the 5th plus log base 4 of x to the 7th plus log base 4 of y to the 4th power. Okay, so then all of these are adding, so we are going to go ahead and change that to multiplication when we put them as single logs. So I'll have, log base 4 of 2 to the 5th times x to the 7th times y to the 4th. And then you'd want to simplify that. And so I end up with log base 4, 2 to the 5th is 32, x to the 7th, y to the 4th. And that is my final answer.